Go.
Hi, welcome everyone. My name is Dr. Patricia Craig, and I was host of the Astrobiology session this week at GoSciTech. The students are going to give a brief summary of what they did, some of the cool activities they did, so I'm going to let them go ahead and start. Come on up.
So on Monday we discussed the characteristics of life and how you can identify life. Some of the characteristics that we studied were reproducing, the ability to grow and develop, and having DNA. And it's important because some things like hurricanes are able to grow and develop just like us, but that doesn't necessarily mean that they're life.
Also on Monday we created scales of the solar system. We each made a scale out of a meter of receipt paper, and then we all coalesced and made a big one in front of the school.
To conclude Monday, our class conducted an experiment. In 3 jars, we poured hot water and then sealed them shut with the carbon dioxide detector. 2 of the jars created a large amount of carbon dioxide, implying that the samples contained an organism, but only one of them continued to produce carbon dioxide after an extended period of time.
In class, we also learned about spectroscopy, which is the study of using light to identify different wavelengths. And this is an example of a spectroscopy of different gases, and that's what they would look like for their spectra. This is a spectrometer, which would be used to look at spectra. And we also learned about planetary exploration, which these 2 pictures both look like they could have been low quality pictures of Earth, but they're actually of Venus and Titan. And then this is one of the ways that we can use to look, like, explore planets, which this is a orbit or a flyby.
And we also did a project on how light works in general. So we had 2 bottles of clear substance, which appears to be water, but one is not water. One is actually tonic water. This occurs because of an ingredient called quinine. It absorbs UV light and releases it, which causes it to glow blue. So this is tonic water. This is regular water.
In the first part of the day, we watched the movie The Martian, and we looked at how scientifically accurate it really is. In the beginning of the movie, our person, the main character, he gets hit by a flying antenna during a dust storm and gets blown off the path. That could have never happened in real life because the wind on Mars is not strong enough to blow anything up more than dust.
Although human exploration for Mars may be far away, we've already collected our fair share of data through landers and rovers sent to Mars as early as 1997 with Sojourner, and as recently as 2021 with Perseverance. And that's a picture of Perseverance.
The first thing we did on Wednesday was talk about and look at the moons of the solar system, and in my opinion, the most interesting ones we looked at were the Galilean moons of Jupiter, which were first seen and discovered by Galileo in 1610. And this is an example of Jupiter's second largest moon, Callisto.
Afterwards, we discussed extremophiles. When taken apart, extremophiles roughly translate to love the extreme. So, an example of this would be a tardigrade. They can live in extreme temperature or space areas with like high pressure and more. And then
And the last thing we talked about on Thursday was exoplanets and how to find them. Okay, so exoplanets are planets that are found outside of our own solar system. They can be generally classified into 4 different categories based on their properties, like gas giants. They're made of gas. There are many different ways to find them, but the most common way we've discovered, all the ones we've discovered, is transit. That's Kepler 22b. It's an exoplanet.
And also on Thursday, we learned about the Drake equation, which was made in 1961 by Frank Drake, who is named after. He had formulated an equation to calculate the probability of gaining any form of communication with extraterrestrial life. While many of the values are still based on theory due to our lack of data, mostly the F's you see here, it still does give us insights on life that is beyond Earth, obviously. And if you look at the equation, you have n equals, which n is how many civilizations that have communicative abilities that we can contact, which equals r, which is how many stars form in the galaxy every year. In our galaxy, it's about 7. And then the next part of the equation is how many of those stars have planets. It's about 0.9. And I swear, like, I cannot see that, but that's how many of those planets are habitable as of what we know, which is about 0.1. And everything else, as I said before, is mostly theory. And all of that is multiplied by how long those civilizations have been trying to communicate with us, if they have at all.
Okay, so finally, life out there. Currently, there are no signs of life, extraterrestrial life. In 1977, 2 gold photographs were manufactured alongside Voyager 1, and records contain sound images portray the diversity of life on Earth. Similarly, in 1974, the Arecibo message was released into interstellar space via radio waves. It contains a brief summary of the humanity and Earth.
Excellent. So again, thank you all for watching. Parents, thank you for sending your kids to GoSciTech. I hope they had a lot of fun and they learned something in the meantime. I'd also like to thank our 2 student assistants, Dixie and Dara, who helped us through all of our week and our fun activities. So thank you.